Welcome to the session on sequences and series, arithmetic sequences. The objectives for this session are to find the nth term of an arithmetic sequence. An arithmetic sequence is a sequence in which the difference between consecutive terms is constant. We're now going to take a look at some examples. One example will be of an increasing arithmetic sequence. Another will be of a decreasing arithmetic sequence. And another will be of a sequence which is not an arithmetic sequence. Let's take a look at the first example. An increasing arithmetic sequence example can take the form 3, 7, 11, 15, because notice that this is increasing by the same constant. We're adding 4 each time as shown. Now let's take a look at another example. A decreasing arithmetic sequence example is 27, 22, 17, 12 and so on. Notice that this sequence is decreasing by 5 each time. So we're subtracting 5 to get to the next term. And now for the third example. A sequence which is not an arithmetic sequence can take the form 3, 5, 9, 15. Notice that this sequence for the first two terms has increased from 3 to 5, which is an increase of 2. Between 5 and 9, this is an increase of 4. And between 9 and 15, this is an increase of 6. So consecutive terms are not increasing by a constant each time. The formula for the nth term of an arithmetic sequence is u subscript n equals a plus n minus 1 times d, as shown on your screen. U subscript n is the nth term, a is the first term, and d is the common difference. Now let's take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's take a look at part A first. The nth term of an arithmetic sequence is u subscript n equals 43 minus 3n. We are required to find the first 4 terms of the sequence. So let's solve this. We are simply going to plug in the values n equals 1, n equals 2, n equals 3 and n equals 4 into u subscript n each time. So when n equals 1, we have u subscript 1 equals 43 minus 3 times 1. Which is equal to 40. When n equals 2, we plug in n equals 2 into the formula for u subscript n to give 43 minus 3 times 2, which is equal to 37. When n equals 3, we have u subscript 3 equals 43 minus 3 times 3, which is equal to 34. And finally for the fourth term, when n equals 4, we have u subscript 4 equals 43 minus 3 times 4, which is equal to 31. So the first four terms of this sequence are 40, 37, 34 and 31. And now for part B. We are required to write down the 78th term of the sequence. So let's solve this. We're simply going to plug in n equals 78, as shown here, into the formula for u subscript n. And this equals minus 191. And now for part C. We are required to write down the first negative term in the sequence. So let's solve this. We need, in other words, to find the smallest value of n which satisfies u subscript n is less than 0. In particular, we're looking to find the smallest n for which 43 minus 3 times n is less than 0. Rearranging this gives us 43 is less than 3 times n, which implies that n is greater than 43 over 3. In other words, n must be greater than 14.3. In other words, we have that n is equal to 15 because this is the smallest value, or smallest whole value, which is bigger than 14.3. So when n equals 15, we plug in n equals 15 into the formula for u subscript n to obtain 43 minus 3 times 15. And this is equal to minus 2, which is of course less than 0. So in other words, the first negative term in the sequence is u subscript 15 equals minus 2. And now for another example. Pause the video and have a go. Press play when you're ready to view the solutions. Let's take a look at part A first. We are required to write down the nth term of the arithmetic sequence. So let's solve this. The first term is a equals 3. The difference, or the common difference, d, is equal to 7 minus 3. Which is equal to 4. We now simply plug in the values into the general formula for u subscript n. Remember that u subscript n is equal to a plus n minus 1 times d. And so if we plug in the values of a and d, we obtain u subscript n is equal to 3 plus n minus 1 times 4. And rearranging this equation gives us that u subscript n equals 4n minus 1. And now for part B. We are required to write down the nth term of the arithmetic sequence 52, 47, 42, 37, 32, and so on. So let's solve this. The first term, a, is equal to 52. The difference, d, is equal to 47 minus 52, as shown. And this is, of course, equal to minus 5. We can now substitute this into the general formula for u subscript n for an arithmetic sequence. The nth term is equal to a plus n minus 1 times d, as shown. So plugging in the values of a and d gives us that u subscript n is equal to 52 plus n minus 1 times minus 5. Rearranging this equation and tidying up gives us that the nth term is 57 minus 5n. Let's now take a look at another example. Pause the video and have a go. Press play when you're ready to view the solutions. So let's solve this. We have a sequence which is generated by the formula u subscript n equals c plus dn, with constants c and d which are to be found. Given that u subscript 4 equals 2 and u subscript 9 equals minus 8, find the values of constants c and d. We're going to begin by substituting u subscript 4 equals 2 into the equation for u subscript n. This will give us u subscript 4, which is equal to 2, equals c plus 4 times d, where n is equal to 4. We're going to call this equation equation 1. Similarly, we're going to substitute u subscript 9 equals minus 8 into the equation for u subscript n to give us minus 8 equals c plus 9 times d, where n is equal to 9. Now we have two simultaneous equations, equation 1 and equation 2 as shown. If we subtract equation 2 from equation 1, we obtain 10 equals minus 5d, as shown here. And so solving for d gives us that d equals minus 2. We can now substitute this value of d into equation 1 to help us solve for c. So we have that 2 equals c plus 4 times minus 2, which is the value of d. And this, of course, implies that c is equal to 10. This brings us to the end of this session. If you have understood its contents, you should be able to find the nth term of an arithmetic sequence. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.